Welcome back. Today we're going to be looking at functools in Python. And of course functools works with functions in Python, and it's for higher order functions, so functions that act on or return other functions. And in general, any callable object is a function, because of course there's a difference between a function and a callable object, but it is very subtle. And what it's saying is that the higher order functions work with your functions to do other things. And obviously this sounds very confusing, so we'll have a look at some real examples. So if we're going to use it, the first thing we need to do is import everything. So we just say from functools import star. And the first one, this is a factorial function. So to calculate n factorial, it multiplies n by n minus 1 factorial. And so we can define it and work out 10 factorial. And so it's calculated 10 times 9 times 8 times 7 and so on. However, we've got this cache, so that means it only ever calculates the value once. So now when we work out 5 factorial, it goes to the factorial function and sees that 120 has already been calculated, because 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 factorial, which is already worked out. And if we work out 12 factorial, it only has to do 2 steps, which is 10 factorial times 11 times 12. And we can actually see the cache info. So you see we've had 2 hits where we worked out 5 and 10, and 13 misses where we've worked out all the other values. And currently the size is 13. We can do the same with Fibonacci numbers. So this returns n if n is 0 or 1. Otherwise it returns Fibonacci of n minus 1 plus Fibonacci of n minus 2. So it's working out the nth Fibonacci number. And again we've got the cache. We can work out the 10th Fibonacci number, the 20th, and we can see when we've been working out these numbers we've had a lot more hits, because when we work out Fibonacci n minus 1, we then work out Fibonacci n minus 1 again, which is the same as Fibonacci n minus 2. And so that was a lot more efficient than if we just did it every time recursing to the base case. Another cool thing that it can cache, if we import random, so what we've got is this data class, and it works out 100 random numbers, and then the mean is the sum divided by the length. However, because we're caching this property, that means the first time we call it, it works out the mean to be this value. However, the second time we call it, it doesn't need to work it out again. And for this example, of course, it's not a huge thing, because the sum function is very fast and the length function is very fast, but it still drastically saves time in bigger programs, and if we were to do it 100 times, it'll be a lot quicker using this cache property. You can also do it with, for example, standard deviation, or any other type of value that gets calculated once but never again. We can also have an LRU cache, and this is like the cache, but it's smaller and a little slower, because it can only store a maximum number of values in the cache, and you could set the max size to none and then it's the same as cache, but here we've set the max size to 10, and so this just does letter to number, so it takes a letter and converts it to a number. And you can see if we go through all these letters, it goes from 0 to 25, and we can see the cache info, and of course every time it's missed. However, currently it's only got 10 items in, so if we work out these next two, when we go to B has been removed from the cache because it's stale, it's been in there too long and we need to make space for something else. However, X is still in the cache, and X is the 23rd letter. And we can actually see the cache info, and it says that we had 1 hit, and that was with the X because we missed when we were looking for the B. However, if we were to do it again, we'd get another 2 hits, because those values are now in the cache, and you can see we've got another 2 hits. Another thing is you can use the functools to create this ordering. So this is just something called X, and it has a value, and we can compare values. So we say if one is equal to the other, we say this one is equal to the other one in terms of their value. We can also check if this one's greater, if their value is bigger than the other value. So if we run this and then run this, you see we get an error because it says this less than or equal to is not supported between instances of X and X, and that's because we haven't defined a less than or equal to sign. However, if we use this total ordering, then it now defines that method for us, and you can see in both times it's true. And that's why this total ordering is really useful, because it allows you to work out whether stuff is greater than or equal to by checking both, rather than having an error when your code runs. Another one of my favorite functions is reduce, and this is really interesting because the reduce function was actually removed in quite a recent version of Python and demoted to this functools module, because it used to be a default. But now we can import it and create this function which accumulates all the numbers. So it takes a list and reduces it to a single value. And so here we've just added up all the values, here we've multiplied them together. But what if we wanted to define a function where we multiply them by one more than the current value? Maybe you want to work out the number of factors and you've got a list of their powers or something. So you'd think the obvious answer is we multiply x plus 1 by y plus 1. However, that doesn't work, because what we have is we have this accumulator in our function and this current value. And so what we're doing is we're multiplying the accumulator by the current value plus 1. And so, because here we're multiplying the accumulator plus 1 by the current value. So let's say for the first one we go 2 times 3, we get 6, and then we want to multiply 6 by 4 to get 24. However, what this was doing was it was adding the 1 to the 6, so it was doing 7 times 4, which is not what we wanted, and so we can fix that here. The only thing is, this value is still too small, and that's because when we start with 1, it says the first value is 1, so it does 1 times 3, and then 3 times 4, and so on. But actually, we want this to be a 2. So we can set our initial value of the accumulator to be 1, and obviously if you set that to 0, it would just multiply everything by 0. So this time, it will work. And of course we can check this, because this is just 6 factorial divided by 1, because we haven't got the 1 at the end, although we do here, so it's just 6 factorial. And that works out to be the same answer. So this reduce function has an accumulator and a current value, and an easy way to remember that is that they're in alphabetical order. And then at the end you can have a start value, and the default for the start value is the first value of your list rather than 0 or anything. So you can see functools has a huge array of different functions that work with functions and are really useful and do some really cool stuff to optimize your code. So hopefully you've enjoyed this video. You'll use functools in your projects now that you see that they're a hidden gem. And I'll see you again, same time next week. Till then.